So we want to use inequalities when solving absolute values. So absolute values are basically saying the distance from 0. So if we have something like, say, absolute value of x equals 5, then we know that that's saying how far is the distance, how far is 5 from 0. So absolute value is a distance. It's saying how far is something from 0. So we can use that because if it's a distance, that means it's always positive. We can't have negative lengths of something. So if we're having an absolute value being less than 5, then we're saying what distances from 0 are less than 5. So obviously 4, 3, 2, 1 would all be less than 5. But going to distance the other way would also be less than 5. Negative 1 would be a distance. Negative 1 to 0 would be 1. So that's less than 5. Negative 2, negative 3, negative 4 would all be still fitting into this inequality. So when we're working with absolute values, we kind of want to look at both sides. We want to say, where is it less than 5? Where also is it greater than negative 5? So absolute values turn into two-sided inequalities, basically. So if we do that with an actual example, one where we at least have to do one operation. So let's say absolute value of x plus 2 is greater than 7. We want to find out where this inequality is greater than 7. So, or where this absolute value is greater than 7. So if I look at this, I'm trying to say where is this whole thing greater than 7. So where this absolute value would equal 8 would be greater than 7. Absolute value would equal 9 would be greater than 7. So again, on one side, we can still just say where is that greater than 7. On the other side, though, if this inside was negative 8 or this inside was negative 9, because absolute value is a distance from 0, really it just turns everything positive. That would also be greater than 7. So I'm going to try to find out where it's less than negative 7. So again, I'm kind of a two-sided. I'm going to solve it. So I'm going to subtract 2 from both sides. So I have negative 9. It's greater than x is greater than 5, which makes no sense actually. If I have something that's less than negative 9, it can't also be greater than 5. So I'm not really going to write this out as an inequality. I'm going to go ahead and write it out with set notation. I'm going to say this one side is negative 9 is greater than x, so x is less than negative 9. So my lowest would be negative infinity. My highest would be negative 9. I'm going to use parentheses for both because it doesn't equal it at any time. Then my other side would be x is greater than 5. So my lowest on that side would be 5, and it would go all the way up to infinity. Again, parentheses on both because it never equals it. I'm going to use a union because in set notation, union is and. So again, let's just check, make sure this makes sense. If the inside of this was, say, negative 11, negative 12, negative whatever, then yeah, that would be greater than 7. And on this side, if it was, my x was 6, 7, 8, all of that would also be greater than 7. So my answer makes sense.